How's it going? So today I'm just going to be going over um, what debouncing is and why we want to use it for some of our code. Now, debouncing is just something that makes sure that we don't call functions more than we need to. Um, the reason this is important is because if we are doing something like using a human machine interface and trying to scroll through a menu, um, we don't want to scroll too many times. We don't want to go past things. We don't want to count scrolls more than the user is inputting them. Um, and also for things like uh, buttons, if we don't want to read too many button presses, or we don't want to um, have a motor like change directions too many times based on button presses, things like that. Uh, and so I'm just going to show you a couple of methods for how debouncing works. The first one I want to show is just a debounce based on time. So based off of um, not activating a function until a certain amount of time has passed since it happened. The way I'm doing this is just a simple if a button has been pressed, and if it wasn't just pressed, then the LED comes on. That's just what I have for my code. Obviously, for you, it'll be whatever function you don't want to activate too many times. And then once the button's pressed, it says, hey, this button's been pressed. Um, now I'm just using a timer callback for the delay to make sure that you don't activate the function too many times. If you just want to go back to your timer interrupt lab, you can probably find very similar timer callback code. And all this is doing is the basic timer interrupt and then saying if this button's been pressed, then count the button, like increment the time since the button has been pressed. And then if it's been 3,000 milliseconds, 3 seconds since it's been pressed, and say um, it's no longer being pressed, and say that uh, it's ready to restart the time once it is pressed. My LED on stuff is just saying, hey, keep the LED off if it shouldn't be on, and then um, have the LED on for a second. So that's just this. If LED is on, then turn on the LED, increment a timer. Once that timer hits 1 second, LED turns off. And this is just like my basic code for the function I don't want to run a lot because I don't want to restart this LED timer a bunch of times. I just want it to run once, be done, and not count too many button presses and restart the time over and over. Um, and all this really comes down to is, let me program it, and let me go back to this screen. So all it is, I have to set it to the main real quick. Hold on. Uh, set as main. Okay, I can program it. And this should be good. Just make sure program's running right. Yep. Okay. Cool. I put that to the screen. And so I just have basic setup, Google button, and a system that is not really working. Yeah, this button's super finicky, but I have it this way because it'll be useful for the next lab um, or the next demonstration. Okay. Okay. So the code is just push the button, LED comes on. Obviously, I wasn't still pushing it, so nothing happens. If I push the button and keep pressing it, nothing's going to happen for 3 seconds. And then once that time's passed, I can push it again, reactivate it. If I hold it, still nothing until 3 seconds goes by, then it activates it again. That's just like if you are okay with activating it every 3 seconds, you can do that. But the basis of the code is if I press it and hopefully it works, then I can't keep pressing it until it's ready to reset. Um, but yeah, press it multiple times, nothing happens, resets, and then once the Once the wires are in properly, it goes again. Uh, yeah, that's just have a function go. You don't want the function to go too many times too quickly, so it won't. And obviously, if you're doing like a human machine interface, if you're pressing a button and you don't want to just like have it press for a millisecond or half a second and it scrolls through everything, um, you can set the delay for something much smaller. Instead of having my 3,000 second delay, you could just have like half a second, a quarter of a second, whatever you want to make it more fluid, um, just depending on what your purposes are for the code. And the next version of this code is just, it's pretty similar, but not really. It's the same basic LED function where the button's pressed, LED is on for a second, and then it is no longer being pressed. But the difference is instead of uh, having a time before I can press the button again, it's just, was this button just being pushed a second ago? It was the last read, the button being pushed, or was it not? Um, and the way I implement that is just saying if the button last was not being pressed, uh, and if I get the value right now, it is being pressed. The onboard buttons are backwards, so this is being. It looks better here. Um, I'm using both buttons for this, the onboard and offboard. So if it was just not being pressed, if it is currently being pressed, then turn the LED on, say that it has just been pressed, and set the LED high, or do my LED function and then set another LED high. This is just for showing the button press and uh, demonstrating the code in a different way. And then obviously, if the button is not currently being pressed, say that it is not currently being, or say that it just a second ago was not being pressed. Um, and my LED on function the exact same. Turn the LED on for a second, turn it off. And so the way that this should work is if I am holding down the button, the LED should turn on for 1 second and then turn off and stay off while I'm holding the button down. Um, and it should reset once I let it go and I'm able to press it again and the button should come back on. Now, this both does and doesn't work depending on the setup for the button, whether or not its connection is poor, whether it's finicky. If it's a solid connection, it generally works. And so for my setup right now, I have it to where this blue LED is always on while I'm able to put in an input. So while I am accepting a button input, the LED is on. If I press this button, LED comes on for a second, and I'm ready for another input. The LED is coming on because of this. That's the finicky one. But if I hold this down, then that LED comes on, turns off, and nothing else happens. You can see that the blue LED is not coming on because I'm not accepting any input. When I let go, I am now accepting another input. I can go again. And similarly, if I just keep pressing it, it will not let me put in another input. This blue LED is not coming back on because it still thinks that I'm holding it, or it's still saying, hey, you were just pressing it. So we're not going to let you do that again. But once I let go, give it a second, it's back on, and I can put in another input. Now, this works much differently for this button, because this button will not read at all for some reason. Let me try to figure out these connections. There we go. Yeah. Or there we go. Okay, so yeah, this button has a much less stable connection. And so if I hold the button down, it keeps that yellow LED on, even though if the button is being held down, it should not stay on. This red LED comes on every time this button's being pushed, so it's different than the blue. I just want to show visually how it being pushed is like. And it is just a lot less stable. So the reason that that yellow LED is staying on is because this button, due to its instability, is sending in a lot of ones and zeros mixed up. Um, and so just a lot of inputs that I'm not looking for. This button sends a steady flow of ones when I'm pushing it down. Therefore, the button or the LED turns on, turns off like it should, and it works properly. This one, on the other hand, I'm not even pressing it, and it's saying, hey, you're pressing the button. Clearly a worse connection. Um, when I'm holding it down, which I am right now, I know it's hard to tell, holding it down, that LED just does not turn off, even though it should. And so a way to fix that is by, or one method that you could use to fix that if you do like this method more and you have an unstable connection, you could simply add a lot more of lasts for the button, and you can call it like last one, last two, last three, last four, last five. And what this does is it's just saying if the last five inputs or six inputs were off, then I'll let you turn on. If the last six were on, or if any of the last six were on, then I will not let you redo what you were just doing. I will not run the code again. And this is not bad, but it could introduce some latency into your code, and it could just make the user annoyed because you have to press it and wait for the last six to read. I wasn't pressed for the function to go. Um, so it could be useful. It could not. Uh, that's something for you to try out, figure out what kind of debouncing you are more comfortable with, which kind of debouncing you like more. Um, Personally, I like this kind more uh, because I don't like having hard coded in time delays. I am much more of a fan of um, saying, "Hey, was I just pressed? If I wasn't, then go ahead." Uh, I would say if you have a very unstable connection, definitely go with the straight timer based one. That way, you don't have code activating constantly when it shouldn't be, or just make sure you have plenty of checks for if it is or if it should or should not be reading as pressed. Um, that's really all that I have to show. Uh, Other than that, these have a lot of different uses, like for a scroll wheel, like I talked about before, or not scroll wheel, but if you're scrolling through an interface, it's very useful for not skipping options in the interface. It's very useful for um, activating a motor's function only once when you don't want to activate it over and over again. And it could also be useful for uh, sensors if you're getting kind of unstable readings from a sensor, if you want to make sure that you're checking the last few. Like, oh, if my sensor was reading this value for the last few senses, then activate this function. Or um, if my sensor is just getting a bunch of jumbled data, don't do anything with it because it could cause issues with the rest of the code by activating different things at different times that you don't want to be activated. Um, yeah, I hope that helps with you debouncing your code. It's pretty simple. It's all code based. No hardware needs to be done. This was just this system is just very easy, very simple to demonstrate how it works, and when it doesn't work. And I hope that helps.